Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams lived long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps, each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.
A powerful burst of gamma radiation lasted a mere half-second, but it released an enormous amount of energy. It was more than our sun would produce in 10 billion years. This brief flash lit up the whole sky. Afterward, a much softer and more long-lasting glow replaced it. Astronomers examined the phenomenon with X-ray, radio, optical, and infrared waves. It turned out that people had finally seen a newborn magnetar for the first time ever. It was likely formed after 2 neutron stars had merged. It resulted in a kilonova, one of the brightest and largest stellar blasts. Its light finally reached our planet on May 22, 2020. Imagine a massive star, at least 5 times the mass of our Sun, reaching the end of its life. It might be because it's run out of its nuclear fuel. If it happens, the star starts to cool off. The pressure inside drops, and the gravity starts to squeeze inward. And then, more than 1,000,000 times the mass of our planet collapses within 15 seconds. It happens so fast that an enormous shock wave causes the outer part of the star to blow up. It produces a blinding burst of light. This powerful blast is called a supernova. What's left behind is an incredibly dense core with a huge cloud of hot gas, called a nebula, expanding around it. If the star has been massive enough, more than 10 times the size of the Sun, it's likely to turn into a black hole. If not, it turns into a neutron star. It's basically a giant nucleus, the central part of an atom. These stars are mostly made up of neutrons and are rarely larger than 20 miles across. For comparison, our Sun is almost 865,000 miles across, which is 109 Earths put side by side. But don't let this relatively tiny size fool you. Any neutron star is at least 1.5 times heavier than our Sun and has an intense magnetic field. If you scooped just a teaspoon of this star's insides, this matter would weigh more than 1 billion tons. It's so dense that it makes neutron stars some of the most extreme objects people know about. The next stop is the black hole itself. When 2 neutron stars merge, they most often create a new, much heavier one. Within milliseconds, or even less, this star collapses into a black hole. But the astronomers who examined the flash of light recorded in March think there might be another outcome. They're almost sure they saw something never observed before: the birth of a magnetar. That's a rare form of a neutron star with an ultra-strong magnetic field. It's 1,000 trillion times stronger than our planet's. This field is also so powerful, it heats the star's surface up to 18 million degrees Fahrenheit. To put it simply, magnetars are the most powerful magnets in the universe. Their magnetic fields can seriously mess with the neighborhood. Atoms, unlucky enough to get close to such a star, get stretched into pencil-thin lines. If you somehow found yourself several hundred miles away from a magnetar, it would end badly for you. The magnetic field would first disrupt your bioelectricity. It means that your nerve impulses wouldn't work anymore. Even your molecules would change under the influence of the star's field. In the end, you'd pretty much vanish. If a magnetar flew within 100,000 miles from our planet, it would wipe out all the data on every single credit card in the world.
About 800,000 years ago, I wasn't around then, a gigantic asteroid soared through space and plummeted toward Earth. It slammed into our planet with enormous force. It blanketed 10% of Earth with shiny black and green lumps of rocky debris known as tektites. Tektites are pieces of rock that get liquefied by the heat of a meteorite impact. Then they cool down to look like dark, glassy pebbles. A trail of these tektites was strewn across Southeast Asia and reached all the way to eastern Antarctica. This is how scientists know this giant meteorite crash happened. Well, researchers spent nearly 100 years trying to find the gigantic crater caused by the impact. But tektites were too widespread. That's why they couldn't pinpoint the exact location until recently. A team of experts from different universities tried to discover the ground zero of the meteorite impact. They investigated several craters in China and Cambodia, but none seemed to be created by a meteorite crash. The experts then decided to investigate Laos. It's a country where they discovered the largest and most concentrated number of tektites. After ruling out all visible craters, the team came up with a new theory. What if the crater is hidden by something? In search of the potential crater, the scientists measured gravity readings at different locations all across Laos. At the site of an ancient volcanic eruption, below thick, dense layers of cooled volcanic lava, they discovered a severe gravitational anomaly. It turned out to be a large, elongated crater, over 300 feet deep and spreading 8 miles wide and 11 miles long. Based on the location and the crater's enormous size, scientists believe this is the impact site of the ancient meteorite. Meanwhile, over 2 billion years ago, long before the age of dinosaurs, Earth was struck by one of the largest asteroids to ever hit our planet. The asteroid was approximately 6 to 9 miles across and created the biggest impact crater on Earth. This is the Vredefort crater. You can find it in present-day South Africa. When it was formed, it had a gigantic diameter of 186 miles. Over the centuries, the massive crater slowly eroded away into the Vredefort Dome. That's a rocky hill formation that was the central site of the asteroid's impact. This formation is so large that it can be seen from space. Today, the Vredefort Dome is a recognized World Heritage Site. It's also home to several towns and communities that encourage tourists to come and visit the ancient crater. In 1943, one pilot strayed from his regular flight path to avoid dangerous weather conditions. Flying over Quebec, Canada, he spotted a large, perfectly circular basin. That is how the Pingualuit crater was discovered. Around 1.4 million years ago, a meteorite hit this spot, creating this small but deep impact crater. It has a diameter of 2 miles and a depth of 1,300 feet. A lake of deep blue water has formed at the bottom of the crater. It's said that this lake contains some of the purest water in the world as it has no inlets or outlets. It means that the lake is only filled by rains and melting snow. The lake is home to one species of fish, the Arctic char. The Sudbury Basin is also in Canada. Formed over 1.8 billion years ago, it's one of the largest and oldest impact craters in the world. It's located in Ontario, but the impact from the collision was so powerful that debris from it was found 500 miles away in Minnesota. Unlike most impact craters that have a circular shape, the Sudbury Basin is an oval. It's 39 miles long with a width of 19 miles. The original impact site might have been a whopping 10 miles deep, but its modern-day version is much shallower. The asteroid that created the basin carried a high concentration of natural minerals. This made the soil in the crater incredibly fruitful. Today, its floor is home to numerous fruit and vegetable farms. The unique crater formation of Sudbury Basin was used to train Apollo astronauts before they embarked on their missions to the Moon. Perhaps the most famous meteorite of all is the Chicxulub. That's the meteorite responsible for wiping out 75% of all plant and animal life on Earth, including the dinosaurs. The Chicxulub meteorite had a diameter of 6 miles when it struck Earth 66 million years ago. The crater now lies off the coast of Mexico, hidden deep beneath the seabed. It's around 93 miles across and 12 miles in depth. Recently, scientists managed to drill deep down into the highest peak of the impact crater to collect rock samples. They discovered that the disappearance of dinosaurs wasn't caused by the giant size of the meteorite or the scale of the blast. It was because of the exact location where the Chicxulub hit Earth. The meteorite struck part of our planet that was densely filled with a mineral compound called gypsum. It's a soft sulfate mineral that is typically used as a fertilizer. The collision blasted so much sulfur into the air that it blocked out the sun. This caused the prolonged dark winter that doomed the dinosaurs. One of the youngest craters on Earth is the Barringer crater in Winslow, Arizona. The Barringer crater is also one of the best preserved craters on Earth. It was formed 50,000 years ago when a heavy meteorite made mostly of iron plummeted down from space. Earth's atmosphere barely slowed down the massive chunk of metal. It collided with the ground with incredible force. The meteorite vaporized upon impact, leaving very few remains. The crater left by this powerful explosion was named after the man who identified it in 1903. It was a mining engineer named Daniel Barringer. The diameter of the crater is 3,900 feet and it goes 560 feet deep. The Barringer family still owns the impact site to this day. You can visit the crater and take a guided tour around its rim. The Papagai crater in Siberia is one of the most interesting craters on Earth. An asteroid impact over 35 million years ago formed this massive basin. The crater is 62 miles across, which makes it the fourth largest one in the world. This crater is unique as it's home to one of the largest diamond deposits in the world. The intense pressure from the collision transformed the graphite at the impact site into diamonds. Scientists say that the crater contains trillions of carats of diamonds, but no one has ever mined them due to the site's remote location and lack of infrastructure. In the year 1530 BCE, a meteoroid entered Earth's atmosphere before shattering into pieces. The meteorite's burning fragments rained down on Earth and crashed into the planet's surface. As a result, a group of craters appeared on a small Estonian island, Saaremaa. The largest crater is a 360-foot-wide perfect circle. It's 70 feet deep and filled with blue water. 8 smaller craters that appeared during the collision can be found within a half-mile radius of the largest crater. The impact of the meteorite fragments caused the trees on the islands to catch fire. Almost all forests burned down. Luckily, the woodlands have now grown back, and the craters are a popular hiking destination for tourists. A meteorite struck the area we now know as Quebec, Canada, around 200 million years ago. This collision created the 6th largest impact crater in the world. It had a diameter of 40 miles. Over the century, the outer rim of the crater has filled up with water. It's now known as Manicouagan Reservoir. The impact crater lake is so large it can be seen from space, and its strange shape gave the lake its nickname, the Eye of Quebec. The oldest meteorite crater in the world is in Western Australia. The Yarrabuba crater is 2.2 billion years old. Well, that gets my vote for the best crater name. The impact site is so ancient that the original crater has completely eroded away. Yarrabuba's diameter was around 19 to 43 miles. Scientists managed to figure out the age of the impact site by analyzing the ancient crystals and minerals found within the crater.
Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more. But getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city. Except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system. For years, scientists have been struggling to explain bizarre sounds, some repeating, some heard only once, that come from the dark depths of the ocean. From bewildering hums to worrying bloops, the water transmits outlandish acoustic phenomena. One of these mysterious noises got named the upsweep. For the first time, this long train of sounds was registered in 1991 in the Pacific Ocean. One of the most unusual things about this signal is that it keeps changing, as if trying to confuse researchers even more. Like some unearthly howl, it varies from high to low frequencies and then back again, and you can hear it better in the spring and fall than in the winter and summer. Why the upsweep? It's simple. The sound travels from the bottom of the ocean towards its surface, as if sweeping up. Scientists do have a theory explaining this phenomenon: the activity of undersea volcanoes. Hot lava pouring into ice-cold ocean water could theoretically create such noises, but there's no proof found yet. Plus, the sound has been declining since 1991, even though it can still be detected. The bloop is the name given to an ultra-low frequency and incredibly powerful underwater sound that was recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The bloop continued for approximately 1 minute. Having started from a low rumble, it gradually rose in frequency. It also kinda mimicked the noise created by marine animals, but its volume was so great that no living creature known to science could have made it. When the bloop occurred, underwater microphones managed to record it from a distance of 3,000 miles away. Rumor has it that the noise might have something to do with the fictional half-octopus monster Cthulhu, or some other colossal deep-water creature. But if you don't believe in monsters, science has another explanation: iceberg fracturing. The thing is that icequakes recorded in the Scotia Sea resemble the mysterious bloop a bit too much for it to be a coincidence. The whistle resembles this annoying sound when a kettle of boiling water is telling you it's time to make a cup of tea. But even though it may not be as blood-curdling as some other bizarre ocean sounds, it doesn't make it any less mysterious. Plus, the whistle is very elusive. In 1997, only one underwater microphone was able to pick it up, and therefore, researchers didn't manage to pinpoint the source of the noise. The most likely cause of the sound is an eruption of one of the submarine volcanoes. Have you ever heard of Julia? No, not your neighbor. I'm talking about this otherworldly sound. Listen to it. It was recorded in 1999 by the U.S. National Oceanic and Atmospheric Administration. The source of the sound was most likely a large iceberg that ran aground somewhere in Antarctica. The sound was so loud that it was heard over a huge territory, and its duration was about 2 minutes and 43 seconds. Slow down. That's the name given to a sound recorded in 1997 in the equatorial Pacific Ocean. The sound was called this way because it slowly decreased in frequency over 7 minutes or so. It's been picked out a few more times since it was recorded for the first time. The source of the sound isn't very mysterious. Most likely, it was produced by a massive iceberg that became grounded in Antarctica, or it was caused by moving ice. By that, I mean the friction produced by a large ice sheet moving over land. The loneliest whale sound is often called the 52 Hz whale because the animal that creates it calls at a unique for these creatures frequency. When you listen to this sound, it sounds like a low bass note. At the same time, it's much higher than the normal frequency of the whale call, which rings between 10 and 40 Hz. Interestingly, scientists have been listening to the world's loneliest whale for decades, but haven't managed to figure out its precise location. Nobody knows whether the mammal is male or female, what species it is, or if the animal is still alive. After all, for the last time, its call was recorded in 2004. Earth-shaking booming sounds have been reverberating off some parts of North Carolina for more than 150 years. Called Seneca guns, they're most often heard near the coast. The sounds are so powerful that they often rattle window panes and sometimes vibrate entire buildings. They can last from 1 to almost 10 seconds. Even though scientists haven't cracked this mystery yet, there are some theories. They range from earthquakes to severe distant storms and quarry blasts. But even though the ground trembles every time the phenomenon occurs, no seismic activity coincides with these events. So far, scientists have come to the conclusion that the mysterious sounds happen in the atmosphere, not on or under the surface of our planet. If this theory is true, bolides might be the answer. These extremely bright meteors often explode once they enter Earth's atmosphere. Or Seneca guns might be born in the ocean. Sometimes, when enormous waves collide far away from the shore, you can hear it, even if you're nowhere near the coast. Seneca guns are a type of skyquakes. You don't need to travel to a particular part of the world to hear one of those. Mysterious sonic booms ramble from the sky everywhere, from the US to India and Japan. Just like Seneca guns, this sound phenomenon occurs mostly near the coast or a big body of water. Rattling glassware and windows in the nearby houses, skyquakes could be connected with ultra-fast airplanes breaking the sound barrier. But people started hearing the first skyquakes in 1824. The theories trying to explain this phenomenon include sand dunes shifting, meteors entering the atmosphere, distant volcanoes erupting, Earth's crust cracking during earthquakes, and even gas bursting out of underground vents in the sea or lake bottom. In different countries all over the world, people get paralyzed with fear after hearing otherworldly trumpet sounds that seem to be coming from the sky. The inhabitants of the US, Canada, Australia, Germany, and the Philippines have already heard this hair-raising noise since it was first recorded in 2008. These sounds are sometimes called the sound of apocalypse. And although until recently, nobody could understand the origin of the sounds, NASA claims that there is nothing to be afraid of. The noise can be coming from our own planet. Usually, it's quiet and thus inaudible to the human ear. But when it gets louder, the outcome is the very trumpet sounds that scare people all over the world. Bristol hum started in the 1970s when hundreds of Bristol inhabitants began to talk about a bizarre noise audible only at night. The noise was a low-level hum, and nobody could identify or trace the source of the sound. But the strangest thing about the noise was that one day, it stopped as abruptly as it started. But not before people in other towns across Britain reported hearing similar sounds. Some time ago, the mysterious sound returned. In 2015, a group of French scientists claimed that they had solved the mystery of the Bristol hum. They stated that the culprit was ocean waves that made the ocean floor vibrate. But while it was all good and well, it didn't explain why the sound was around for only several years or why it chose to return. If you ever come to the town of Taos in New Mexico, don't let another strange and unexplained phenomenon send you running for the hills. This phenomenon is a faint, low-frequency hum ringing in the desert air and grating on your nerves. Even stranger, only 2% of people who live in Taos hear this noise. But for those who do, it's unstoppable torture. On top of that, everyone describes the sound in a different way, from a quiet whir to an eerie hum or even persistent buzz. And while some people believe that the Taos hum is the result of unusual acoustics, the others suspect a bad case of mass hysteria. No one has located the origin of the hum yet. On a sunny day, a man was diving in shallow waters near South Africa. At one point, he saw something that didn't catch his eye at first. A pile of shells that looked as if it had been put together. Maybe by some other diver, he must have told himself. But out of all these shells came the most unusual of creatures, an octopus. The gorgeous underwater animal looked straight at the man before swimming away. Impressed by his new acquaintance, the diver started visiting the octopus every day. He watched it use shells and seaweed to protect itself and learned how it hunted and cared for its eggs. All these encounters became the basis for a now famous documentary. In the movie, the diver wanted to study the relationship between a wild octopus and its observer. Initially, the octopus was a bit too shy to let the man get close. But over time, it began to trust him and even explored his body. At one point, the octopus even rested on the diver's chest. The man soon began to look at the underwater creature as his octopus friend. Sure, the documentary did make it look like a true friendship, but that was most likely because of all the close-ups and eerie music. But you can't really know what the octopus is thinking. Maybe what looks like tenderness is just curiosity or confusion. Maybe an apparent hug is really just a defense mechanism. Some people may love octopuses, but can they really be friends with a human? Until they learn to talk, I guess we'll never know. That doesn't make an octopus less of an interesting creature, though. Apart from those quirky sets of tentacles, obviously, octopuses have another characteristic that sets them apart from other sea creatures. A recent study that involved studying the footage of octopuses living underwater shows that they sometimes develop this unusual behavior. They seem to throw things at each other on purpose. It can be anything from dirt from the bottom of the sea to shells or rocks. Octopuses are known to be solitary creatures, so when something or someone, like an underwater camera person, gets too close to them, they might lash out. Just as we have yet to discover the limits of our galaxies and constellations, we know very little about the bottom of the sea. It's one of the reasons why we find it so hard to explain the behavior of some underwater creatures. The truth is, we don't have good enough technology able to deal with harsh conditions and a limited amount of light underwater. You might have asked yourself at one point, what's the deepest part of the ocean? It's called the Mariana Trench. We don't really know exactly how deep this giant hole is, since it's too difficult to measure, but it's somewhere around 6.8 miles deep and 5 times longer than the Grand Canyon. This massive underwater trench was first studied back in 1875 with the help of a weighted rope. Back in 2012, a Canadian film director reached the bottom of the trench in a submersible vessel called the Deep Sea Challenger. Some of the most bizarre creatures on the planet were discovered here, including the Dumbo octopus, the sea cucumber, and the goblin shark. The Mariana Trench got its name from the nearby Mariana Islands, which were named Las Marianas in honor of Spanish Queen Mariana of Austria. The Mariana Trench might be the deepest part of the ocean that we know of. But one other mysterious phenomenon that's interesting for researchers is called phantom bottoms. In the late 1940s, when the sonar became standard equipment, ships and submarines noticed unexpected signals coming from the ocean. Those signals came from areas where no seafloor was supposed to exist. What's even more mysterious is that this fake seafloor appeared to move. One researcher at Scripps University found out that these phantom bottoms showing on maps were indeed alive. They were made out of a layer of jellyfish, shrimps, and other deep-sea creatures. The reason why they move is that they rise to the surface at night to feed. To top it all off, even the way these creatures move is kinda calculated. They don't just move randomly, but seem to gather together by species. We used to believe underwater animals behave this way only to avoid being caught by predators. It's a mystery to scientists why they group in the same way to form a fake seabed. Our curiosity about the deep waters doesn't stop at the seafloor. If you went on a vacation to the beach when you were young, you probably remember the fun of digging in the sand. As the hole got deeper, you may have asked yourself, could I dig all the way to the other side of the Earth? None of us have ever found out. Our parents took us home when it got dark and chilly. Scientists are more reasonable when it comes to this subject. For starters, they know the best place to start digging would be underwater, since those regions are already deeper than what we can find on land. They also do not have the ambition to drill a tunnel through Earth. It's not even possible. That's mostly because of the extreme heat and pressure inside our planet. Even if we could technically dig a tunnel, it would not be safe to travel through it. However, reaching the mantle and retrieving a sample would be a huge scientific achievement, similar to landing on the moon. What we live on is called Earth's crust. Underneath it, there are other layers called the mantle, outer core, and inner core. Researchers have been trying to drill into Earth's mantle since the 1960s, but they haven't succeeded. Some failed due to technical issues, and others were unlucky and chose the wrong places to drill. Our planet's mantle is made of molten rock. Wouldn't that be dangerous if we ever reached it? Scientists say we have nothing to worry about, though. If and when the drillers eventually pierce through the crust underwater, hot molten rock won't pop up the hole and spill onto the seafloor like it would during a volcanic eruption. Mantle rocks aren't solid, sure, but they move slowly, at the same speed as your fingernails grow. Another of those famous deep-sea mysteries is that of the 1997 bloop. You heard that right. I'm talking about a weird sound that seemed to come from deep under the waves. People heard it in the South Pacific. No one had ever recounted a sound like that before. Some thought it must have been emitted by a strange creature living deep in the ocean. It didn't help that the noise came from a location mentioned in a story by famous writer H.P. Lovecraft. In his story, it was a creature called Cthulhu that lived there. In the novel, the author described it as a large, human-like monster with tentacles on its face and wings on its back. For many years, people tried to figure out where the noise came from. It wasn't until 2005 that they concluded it was from icebergs breaking off of glaciers. Some people still don't believe that this explanation truly makes sense and are searching for a different reason for the bloop. If creatures living outside of our planet ever decided to come to visit, you wouldn't expect them to go straight to the bottom of the sea, right? Well, some people claim there's a sort of spaceship on the ocean floor, discovered in 2011. It's basically an oval-shaped object located on the bottom of the Baltic Sea. In 2012, a team of divers explored the anomaly and found what appeared to be a staircase and other structures on its surface. This only added to the belief that the large object had been made by someone and wasn't just a natural phenomenon. Even more bizarre, close to the unidentified anomaly, the explorers' electrical equipment, like sonar instruments and satellite phones, started to malfunction. Some scientists believe it just to be a glacial deposit or some other natural formation, but they still don't know for sure what it is. Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak, but it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythias Oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythias Oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes, and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found, hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn.
More than 1 million Earths can fit in our sun. New research shows that between 20% to 35% of suns eat their own planets, and a quarter of planetary systems orbiting stars like the sun had a chaotic past. The very thing that gives life can also take it away. All the planets in our solar system revolve around the sun, and they all do it in a somewhat consistent way. It's most likely that they stayed that way ever since they first came into the picture, but not all of them. This chaotic existence means that a solar system had a lot of planets in the litter until the host sun decided to melt them away. Our solar system is panned out perfectly so that no planet's gravity interferes with each other. The gravitational force on Jupiter is a lot tougher than Earth's, which means that if Earth gets close to Jupiter, we'd be another moon for Jupiter. The planet is so big that if Earth were the size of a grape, Jupiter would be the size of a basketball compared to it. Even with the best technology in the world, it's difficult to tell if stars do, in fact, eat their planets. The best way to study this is to observe binary systems. That's just a sciencey way of saying a system with two stars orbiting each other. Usually, the two stars were formed around the same time from the same gases and the same conditions. It means they should contain the same elements, more or less. When you open your eyes in the morning, the sunlight that's been traveling for millions of miles greets you. The closer we get to it, the hotter it is. But the rays traveling from the sun also contain certain chemicals that make it unique. The chemicals that are associated with the sun are light materials like oxygen, carbon, hydrogen, and helium. You can find some other stuff in it too, but these are the main ones. By studying these elements, you can learn the history of a solar system with enough detail to determine if it was chaotic or smooth. Scientists studied 107 binary systems composed of suns like ours by analyzing the light. Since each system contains two suns, they compared and contrasted them to see the differences. They observed the stars with a thin outer layer, having different elements than their companion. All suns contain light elements, but there are some that have rocky elements, like iron, silicon, and titanium near the sun. These elements are associated with rough terrains that you'd find on the surface, but they're out there floating in the middle of space. The thinnest outer layer is especially rich in iron compared to the other layers. Many stars are twins at birth. Even most of the Milky Way stars have a buddy in a binary system. It means our sun is pretty unique for not having a partner. But there are some theories out there that suggest that the sun may have lost its twin in the past. It's around 184 light-years away and is called HD 186302. This might be our lucky star. A stellar nursery is where thousands of stars are born. They're made up of gas and dust that gradually collapse under their own weight. Our sun may have started in such a way 4.6 billion years ago. And when they're mature enough, they go out into the open, usually with their travel buddy. Actually, scientists claim that up to 85% of all stars could be in binary pairs or have more buddies, but over 50% are dual pairs. The only problem is that we can't really see it, since it strayed from its original orbit an eternity ago. But traces of it can be found in the Oort cloud. That's the vast cluster of space consisting of comets, space rocks, and ice in the outer edges of our sun's reach. They float around quite a lot, since they're far off the sun's gravity and can easily be knocked out of their orbit into open space. Flying through such a space is no different than flying through any random void of space. The reason why some of these light elements in space contain rock elements you'd find on the surface of a planet is because the sun knocked them off their orbit and devoured them as they got closer. It also happens when a star becomes too big in its place and starts eating everything around it. According to scientists, if a star eats a planet, it can make it go chaotic and spin so quickly that it eventually rips apart. But don't worry, there's a very low chance of the sun devouring the planet in the near future. Stars are formed when a huge cloud of hydrogen and helium grows until it collapses under its own weight. The pressure increases and reaches extreme heat levels we can't even measure. Eventually, the hydrogen atoms lose their electrons, causing the hydrogen to fuse together and release energy, countering the gravity collapsing. But when the gravitational force overpowers the hydrogen fusion, the star begins to expand and becomes a red giant. And then, after around 1 billion years, the hydrogen in the outer core will go away, leaving plenty of helium hanging around, which will fuse with the rest of the elements around. And once all the helium disappears, gravity will shrink the red giant into a white dwarf. And when it's completely gone, the remains of the star release tons of gas and dust into space. Scientists claim that our sun has between 7 to 8 billion years left before it reaches that stage. But even if that becomes a reality, it wouldn't happen overnight. Something like this takes millions of years to take place. But what if the sun decided to devour us overnight as we speak? The planet would start feeling hot in seconds. Every slight degree change can lead to some catastrophic events. Ice caps can melt in a matter of seconds and flood the coastal lands. Even little islands in remote areas of the world will be submerged. And as it gets hotter, every snow-capped area will melt instantly and turn into desert-like climates. Some places will burn, and your everyday objects will melt on the spot. The Earth's interior will also get hotter, allowing volcanic eruptions to happen across the world. Antarctica will melt from the heat, as well as the volcanoes erupting inside. And just in a matter of minutes, the whole planet will turn into fire and ash before it explodes into tiny bits floating in space, reaching areas we've never even heard of. But no worries, something like this won't really happen. In case the sun knocks us off our rotation, the results would be different. It'll also get hot because the magnetic field around us protects us from the sun's radiation. And once we get knocked out of place, the magnetic field gets tarnished, and the extreme heat from the sun will boil us. The gravitational force will be unstable, so the physics of our everyday life will be chaotic. We'll have to wait 5 billion years from now when the sun turns into a red giant. It'll grow in size, eventually eating up Mercury and Venus. Chances are, Earth will also be on the menu. If Earth were to move only 900,000 miles closer to the sun, then it would be uninhabitable. It may seem like a lot, but it's only 4 times the distance between the moon and Earth. Detecting the chemical composition of the sun rays in solar systems that are further away could help scientists find other Earth-like planets. Since the atmosphere around these planet-eating stars changes the chemical composition, we can detect which solar systems out there have had a calm past. The main thing we have to observe is if the planets have a healthy orbit cycle. With nothing else getting in the way, we can assume that the planet could follow the same steps as Earth did for humans to be here. But this process will take ages, since there are millions of nearby stars similar to our Sun. The odds of finding a planet similar to ours are near impossible at this rate. But if so, then there might be life on those planets. There will be no way of knowing if it's intelligent life, but they might have had the same evolutionary fate as us. The Earth has 3 main layers: 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon, and made of nickel and solid iron. It's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years, and it does show. See for yourself. Due to such a long isolation, the conditions inside the Mobile Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. Two miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7-feet-wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long, long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths? There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city. Except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system.
The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international dateline, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic.
Castles were cold places in times past. The stone seemed to radiate the winter chill. This is one practical reason why tapestries were hung upon castle walls, to help keep the cold out and the warmth in. But you just can't hang any old thing on castle walls. It should be beautiful, heroic, with a heavy wow factor. The ancient Greeks hung tapestries on the walls of their castle of the sky, glorious tapestries woven of stars. All 48 constellations of the Northern Hemisphere were designed and named by the Greeks. The story of Andromeda is one such tapestry, woven of 7 constellations spread across the entire autumn sky. The story contains detailed astronomical observations preserved as highlights in the sky tapestry. It begins with the constellation Cassiopeia, queen of the oldest realm in Africa, Ethiopia. When the constellation Cassiopeia is on the horizon, it looks like a staircase going up to the Milky Way. Step pyramids around the world are often thought to have been inspired by the constellation Cassiopeia. In any case, Cassiopeia is a beautiful constellation, indicating that Queen Cassiopeia was also a beautiful woman. She was good-looking, but equally vain, which sets off all the dramatic action. Cassiopeia can be found in the night sky opposite Ursa Major from the North Star. Like Ursa Major, Cassiopeia circles the North Star and is a circumpolar constellation. A supernova was observed in Cassiopeia around 1680 Earth time, Cassiopeia A having occurred about 11,000 years earlier. The Chandra X-ray satellite recently recorded an extraordinary photograph of this supernova remnant showing the elements sulfur, calcium, silicon, and iron amid the expanding cloud's high-intensity X-rays. Cassiopeia's husband is also a circumpolar constellation, a minor, dim one named Cepheus. He had his own kingdom. A merger of empires by way of marriage is something common throughout history. Cepheus was a king of Phoenicia. There were many kings of Phoenicia back in the days when Phoenicia was just a collection of city-states along the western shore of the Mediterranean Sea. Cepheus can be found in the area between Cassiopeia and the North Star. The constellation of Cepheus is important to astronomers. It's where Henrietta Swan-Leavitt discovered variable stars that pulsed at regular intervals. The rate of pulsation of the star indicates the true brightness of the star and enables a sure measurement of the distance to the star. The discovery of Cepheid variable stars was a major breakthrough for early 20th century astronomy. Cepheus and Cassiopeia had a daughter, Andromeda, also a noted beauty, about whom all the fuss is. It seems that one day Cassiopeia was boasting about the beauty of her and her daughter Andromeda. "We are more beautiful than any other women in the whole wide world." Well, such pretension can be forgiven for a queen. But then Cassiopeia went further and stepped beyond all natural bounds. In fact, "We are more beautiful than any of the Nereids." Well, the Nereids were Greek mythological sea nymphs, daughters of the ocean. Noted for their beauty and kindness to sailors, the Nereids, all 50 of them, took offense at being dissed by a mere mortal woman. Cassiopeia had to be punished for exceeding the bounds of the civil order. By her excessive vanity, Cassiopeia transgressed beyond the bounds of nature, for which an unnatural punishment was inflicted upon the entire kingdom of Ethiopia. A monster from the bottom of the ocean, the constellation Cetus, began to devastate the coastal villages of Ethiopia as well as Ethiopia's fishing ships. Fittingly, Cetus is a constellation of the southern celestial hemisphere. The fourth largest by area of all the constellations, Cetus swims in a dark part of the sky called the ocean, with only its head rising above the celestial equator. This part of the sky contains several water-themed constellations, Pisces, the fishes, Aquarius, the water-bearer, and Eridanus, the river. Over 50 exoplanets have been discovered in Cetus. You can bet the James Webb Space Telescope will have a field day analyzing the spectra of these planets' atmospheres, looking for signs of life. Meanwhile, Queen Cassiopeia and King Cepheus must do something about the monster devastating the shores of Ethiopia. They consult an oracle and make another trespass beyond the realm of reason and nature. Tell us, oracle, what can we do to stop the monster from ravaging our kingdom? This monster is not a normal affliction of nature. An offense was committed against the higher realms, and this is the punishment. The monster cannot be stopped by any normal means. Only a human sacrifice of the noblest being may placate the beast. One error compounds another. The noblest person in the kingdom, of course, is Princess Andromeda. According to the command of her father and the consent, or perhaps a suggestion of her mother, Andromeda is chained to a rock offshore. She is the human sacrifice that her parents hope will save the kingdom. Wow. Da-da-da-da! Here comes the Greek hero to save the day, stop the human sacrifice, and turn Cetus to stone. Perseus. Now, where is Perseus coming from? According to legend, the Hebrides. Perseus went to the Hebrides in pursuit of the Gorgon Medusa. The geological scope of this tapestry is incredible, from the Hebrides to the Red Sea. The Hebrides are an archipelago of mostly rocky islands off the western coast of Scotland. It was impossible to sail any further. The Hebrides were the absolute end of the world. Perseus didn't have to sail to the Hebrides. However, he flew on a pair of winged sandals. Hey, way to go, Perseus! Now, Medusa was one of the all-time baddies. One look at Medusa was so terrifying it would petrify you, literally turn you to stone. Perseus was in great danger. So, what did our hero do? Instead of looking at Medusa, Perseus used the scientific principle of reflection. He slew Medusa by seeing her reflected in his polished shield. In our sky tapestry, Perseus is portrayed holding up the severed head of Medusa. In the night sky, one eye in Medusa's head opens and closes and opens again. Arabic astronomers named the star Algol, the ghoul. Algol is an eclipsing double star. One star is bright, the other one, not that much. As the dimmer star orbits the bright star, it passes in front of the bright star, eclipsing it, and the eye closes. Since the dim star takes 2 days, 20 hours, and 49 minutes to orbit the bright star, the eye in Medusa's head opens every day and a half or so. The constellation of Perseus is immediately below Cassiopeia, and skywatchers quickly look to see if Algol is eclipsed, if Medusa's eye is open or closed. Perseus flew back from the Hebrides, accompanied by Pegasus, the winged horse. The central part of Pegasus is the Great Square, made up of 4 stars. As Earth goes around the Sun, the Great Square is right in the center of the night sky in autumn. In the summer triangle of Vega, Deneb, and Altair are in the middle of the night sky. In spring, it's Leo the lion, and in winter, it's Orion the hunter. These are the walls of the castle in the sky, and all have marvelous tapestries adorning them. The constellation of Andromeda shares a star named Alpheratz with Pegasus. It's one of the corners of the Great Square, so it appears Andromeda may be riding on Pegasus. Her crown, remember she is a princess, is floating nearby. M31, the Andromeda Galaxy. To see M31, cross the corners of the Great Square from the lowest star to the uppermost star, and then go a little further to see the Andromeda Galaxy. Be sure to peek at it from the corner of your eyes. It's called averted vision. The corners of your eyes are more sensitive to light, so you'll be able to see the huge spiral galaxy 2.5 million light-years away as a smudge of light 1.5 times wider than the full moon. Now, Perseus doesn't go in for human sacrifice, so he stops it and saves Andromeda by exposing Cetus to Medusa's gaze. And here we encounter the second eclipsing variable in our sky tapestry, Mira, the heart star of Cetus, the sea monster. Mira, from which we get the English word mirror, so fitting in a story about vain beauty, is an eclipsing double star. The dim star orbiting the bright star is a white dwarf, not bright enough to see with the unaided eye. The effect is that Cetus's heart shuts off. Mira is eclipsed and disappears. This cycle repeats itself every 332 days. Our fabulous star tapestry has the only two eclipsing binary stars visible to unaided eyes, the nearest spiral galaxy, and a hero that doesn't like human sacrifice and uses the scientific principle of reflection to thwart mythological monsters. Wow, I would hang that in my castle too. Just saying.